Bismillah ar-Rahman ar-Rahim. Good morning, everybody. Today, inshallah, our video is revision for chapter 17. Chapter 17, metals. Chapter 17 in page 139. So, our lesson today is revision for chapter 17, metals, page 139. Okay, in this chapter we talked about how we can extract some important metals like aluminium and iron. Okay, and I said to you that most of the ores of metals found in the earth in the form of oxides. Okay, so by reducing these oxides we can get the metal itself. Okay, as you see here, I think we underlined this in the class, but also bring your highlight and underline with me. Okay, as you see here, that most metals are found in the earth's crust combined with other elements. Other elements like what? Most of them combine with oxygen. As you see here, we have here iron combined with sulfur. Here iron with oxygen, and also here iron with oxygen. Magnetite and hematite. Okay? Yes. An ore contains enough of the mineral for it to be worth while to extract the metal. Okay, so we use the ore to extract the metals. All this just introduction for our lesson. Okay, extraction of metals, our method of extraction and the reactivity series. According to the order of the elements in the reactivity series, we will decide which way or which method we can use to extract this metal. Okay, and extracting of this metal depends upon what? Depends upon I want to save money, so I use not expensive way to extract this element. Okay, when I try to extract metal, I look to the cost. I look to the cost of the reducing agent and the cost of the energy I use it in extraction, like here. The cost of energy, the cost of reducing agent. Okay, this is what I want in this page, just introduction. Okay, you have to know that the cheapest method we can use to reduce an ore or to remove oxygen from an ore is to heat it with carbon, like this, with carbon or carbon monoxide. But as you know that coke is the cheapest kind of carbon, so we can use it as we use it in extraction of iron, like this. Okay, when I talk about aluminium, I want from you to know that we extract aluminium by electrolysis. So the cost of extraction of this metal is high because electricity is high cost. Okay, so here aluminium, what is the ore we use it here? We use bauxite, and due to that the melting point of bauxite is very high, so we add with this bauxite cryolite. So we dissolve bauxite in a molten cryolite. Take care. Molten cryolite. Why we add this cryolite? Because the melting point of bauxite is very high. So I add cryolite. So we dissolve it in molten cryolite like this. I want this. Okay. We use what? We use electrolysis. This is electrolysis cell. As you see up, cryolite is another aluminum compound that melts at a more reasonable temperature. Okay, important to know how you can label the electrolysis cell for extracting aluminium, and also in case of iron, the blast furnace. Okay, maybe you will find one of them in your exam to label the cell. Here, as you see, we have a steel tank lined with heat-resistant brick. Why heat-resistant brick? Because we use temperature about 1000 degrees Celsius. Okay, this brick lined inside with carbon. Okay, so the electrode I use it here, whatever anode or cathode, is carbon. Okay, and the lined carbon here is the cathode. Okay, and what about the anode? Also from carbon. We put here the molten cryolite and bauxite. Okay, of course, during electrolysis, the molten bauxite will split into aluminium and oxygen. Aluminium is positive, so it will collected around the carbon lining as cathode. Here will collect it to the cathode. The positive will go to the negative electrode. So aluminium will collect it here around the cathode, and we can take it down. Molten aluminium. Okay, and molten aluminium collected at the bottom. What about the oxygen? The oxygen go to the anode, and in the presence of this high temperature, the carbon will react with the oxygen and make carbon dioxide. So you must to replace the carbon anodes from time to time. So it is another cost, but it is not as much as electrolysis, as electricity, because electricity is the main high cost in extracting aluminium. Okay, but here also we have a problem in anodes. This problem that during this process, the oxygen go to the anode, and in this high temperature, oxygen reacts with the carbon and make carbon dioxide. So we have to replace the carbon anode from time to time. Okay, as you see here, that the large amount of electricity needed are the major expense. You have to know the cathode equation of aluminium. As you see here, aluminium plus 3 positive charge and 3 electron negative charge to give me the molten aluminium. Look carefully to this equation. Is this equation oxidation or reduction? Remember with me the oil rig. Oxidation is loss of electron, reduction is gain of electron. So here there is gain of electron. Aluminium ions gain 3 electrons to give me aluminium, molten aluminium. Okay, so it is reduction. Take care. Take care. This equation, very easy equation, but important equation. Okay, in this short paragraph, sorry, your book talks about the problem around the anode, that carbon reacts with oxygen, and we have to replace the anode from time to time, and this is another expense. What about the uses of aluminium? We give you this lesson to know that the metal we extract, we use it in our life. Very important. So the uses of aluminium is very important. Okay? According to the properties of this aluminium, the use will be like here. We use it here in making the body of airplane or aircraft. Why? Because aluminium resists corrosion, has low density and strong. Important. All these uses are important. So why we use aluminium in making the body of airplane or aircraft? Because aluminium resists corrosion, because aluminium has low density and strong. Okay, why we use aluminium in kitchen utensils? Also because it's resists corrosion and shiny in appearance, has low density and good conductor of heat. Okay, so the main reason make us use aluminium in making the body of airplane, that is resist corrosion, low density and strong. I want something low density and strong to fly. And here the most important property that make us use aluminium in kitchen utensils, that is resist corrosion and conduct heat. Plus shiny and so on. Okay. Also, aluminium conducts electricity, so we can use it in electrical cable like this. Very important. Also, we use aluminium in fizzy drinks cans. Okay, the cans made from aluminium because it resists corrosion. Okay, important. So we make the fizzy drinks cans from aluminium because it resists corrosion. We use it in airplane because it has low density, strong, and resist corrosion. Here in kitchen utensils, conduct heat, and in electrical couple because it conducts electricity. Okay. We finished aluminium. We use electrolysis, the cell important to label it. The electrolyte I use is bauxite, dissolved in molten cryolite because the bauxite has high melting point, and the electrode, both anode and the cathode, from carbon. Okay. The main cost in electricity, the cost of electricity, and we have to replace the anode, carbon anode, from time to time. Okay, uses of aluminium, very important. Also, you have to know that we use aluminium in fizzy drinks cans, okay, like Pepsi, 7 and so on, because it resists corrosion. Also, we use aluminium to make windows because it resists corrosion and strong. Now we will talk about iron. How we can extract iron in industry? by using the blast furnace. The blast furnace. Okay? In this blast furnace, we have to add three things. Attention. What are the things we have to add here? In the beginning, you have to know that in this furnace, we have two openings for hot waste gases. For hot waste gases on the top of the furnace, like this. What we have to add in this furnace, we have to add the ore of iron ore. We have to add coke. We have to add limestone. Okay? Attention, look carefully. What is the iron ore? I have to use it here, hematite. So the iron ore is hematite. And we add coke, which is a cheap kind of carbon. Limestone, you know limestone? Calcium carbonate. Calcium carbonate. Okay? Of course, you have to know why we add all these things. This hematite, this is the iron ore. Hematite, Fe2O3. Source of iron. I'll extract iron from hematite, iron ore. Okay? Hematite is the source of iron ore. And we add coke. Why we add coke? Carbon. Because look here, carbon with oxygen make carbon dioxide. Coke is impure carbon. Coke is impure carbon. Carbon with oxygen make carbon dioxide. Carbon dioxide in the presence of carbon make carbon monoxide, which is the main reducing agent. Main reducing agent. Reducing agent for what? For hematite, for iron oxide, to remove the oxygen from it. Okay? As we see here, iron oxide hematite plus carbon monoxide reduce the hematite into iron and give me carbon dioxide. Okay? Attention. This equation is a source of energy because it's an exothermic reaction. When we talked about exo and endothermic reactions, I said to you that all oxidation are exothermic reaction. So here it is a source of heat, source of energy, because it's an exothermic reaction. But this equation explained to me from where I can get the carbon monoxide, which is the main reducing agent. And this equation represents the reduction of iron oxide, hematite, to produce iron. Okay, so here in the blast furnace, I'll add iron ore, hematite, and coke, which is impure carbon. Why coke? Because carbon reacts with oxygen, make carbon dioxide, which is exothermic reaction, source of energy. And the carbon dioxide in the presence of carbon reduced into carbon monoxide. And the carbon monoxide is the main reducing agent for the hematite. Okay? We said we add limestone. What is the use of limestone? Calcium carbonate. We add limestone or calcium carbonate to remove impurities can be found with the ore, like here. The limestone is added to the furnace to remove impurities. Impurities like what? Like silicon dioxide. What are the impurities we have here? Silicon dioxide. Okay? How we can remove this impurity? The calcium carbonate, by thermal decomposition in the blast furnace, split into metal oxide, add regular thermal decomposition for carbonate, calcium oxide, and carbon dioxide. Okay? So by thermal decomposition, limestone, calcium carbonate split into calcium oxide and carbon dioxide. Calcium oxide reacts with the silicon dioxide to make calcium silicate. Calcium silicate. What we call this calcium silicate? You have to know the formula, CaSiO3, okay? And this calcium silicate, we call it slag, okay? You will find it here down. Can be collected on the top of the molten iron, okay? You have to know how label the blast furnace, important. Okay, so the iron ore is the source of iron. The coke is the source of reducing agent and also source of energy. Okay, these equations, important. Okay, and why we add calcium carbonate, limestone, split into calcium oxide with the impurity silicon dioxide makes slag or calcium silicate. Okay, let's talk about the kinds of iron. I said to you, you have a very nice summary here in this table 17.1. okay, how many kinds of iron we have? You have to know the name of the iron kind, kinds, the name of the iron, and the iron mixed with what the percentage of carbon. You can find it with this kind of iron, and of course the uses. Okay, so here we have wrought iron. This wrought iron is pure iron, as you see here. Wrought iron is pure iron. We use it in decorative work such as gates and railing. So wrought iron is pure iron. And then we have mild steel. Mild steel mixed with up to 0.25% carbon. Okay, we use it in nails, car bodies, shipbuilding, and girls. The third kind of carbon, high carbon steel or cast iron. You have to know the two names. الكاست iron contain أو الهاي carbon steel contain 0.25 to 1.5% carbon. Okay. Sorry, I mix it between the two. Okay. So here, sorry, we have high carbon which contain 0.25 to 1.5 carbon. High carbon but contain 0.25. I said this in the class. Use it in cutting tools. So we have wrought iron, pure iron. We have mild steel. Use it in nails, car bodies, and shipbuilding. We have carbon, high carbon steel. Contain 0.25% carbon. We use it in cutting tools. And we have cast iron. Cast iron is the kind of iron contain the very the highest percentage of carbon, which is 4% carbon. Okay, we use it in engine blocks and guttering. So I took till now 1, 2, 3, 4. This is the fifth kind of carbon, stainless steel, which is alloy. Contain chromium and nickel with iron. Okay, we use it in kitchen sinks and kitchen utensils. Okay, very important table 17.1. We have wrought iron, we have mild steel, we have high carbon steel, cast iron, and stainless steel. Okay, as you know, reaction between iron and oxygen, we call it rusting. rusting, and this is a special name for the product produced from reaction between oxygen and iron. Rusting, special term for iron only. Okay. Rusting of iron need to put the iron in the presence of oxygen and water, or oxygen and moisture, oxygen, air and moisture. Okay, like this. Okay, important here, this formula important. The formula of rust is Fe2O3 and the number of water molecules. This number of water molecules varied from kind to kind. So this formula is important. What I have to find to make the iron rust? Oxygen and water. How I can prevent rusting? Prevent rusting by using a barrier. Using a barrier like what? Like plastic. Like painting the iron. As you see here, plastic. Or painting the iron. Prevent rusting by alloying the iron. Mix it with say مثلا chromium and nickel as stainless steel. So how we can prevent rusting? By using barrier like plastic or paint, by using by alloying the iron. Okay, we can also prevent rusting by sacrificial method. Sacrificial method. I'll use metal more reactive than iron, above iron in the reactivity series, so it can be faster than the iron to react with oxygen. Sacrificial method. What does it mean by galvanized iron? Galvanized iron is iron coated with zinc, coated with a layer of zinc. Okay. So this all thing I want from you in chapter 17. What about the questions? I answered these questions with you in the class. Okay. I'll send the answer, photo from the answer with this video. Okay. Take care from this question. We have carbon and oxygen is exothermic reaction to produce carbon dioxide and heat. Carbon dioxide plus carbon produce carbon monoxide, which is the reducing agent. Here equation C, it is the reduction of hematite to give iron, and equation D to remove the impurities. Use the calcium carbonate to remove the impurities to produce calcium oxide, and this calcium oxide I'll use it to react with silicon dioxide to make slag. Okay, here what is the use we can use to extract aluminium? Electrolysis. And what is the cost? Also the main cost is electrolysis. Okay, here he talks about sodium, why did not discovered or produced until early 19th century, because also I need electricity. In this time there is no electricity. What is the ore of aluminium? Bauxite. Okay. Why we use aluminium in different kinds of uses. And this equation about iron blast furnace, you have to know how can label this furnace. Okay, and what does it mean by galvanized steel or galvanized iron? Coat the iron with a layer of zinc. Okay. I finished revision for chapter 17. What I want from you again, I want from you to know all things that I made highlights over them, and this we did in the class. Okay, uses of aluminium important. How we can label this electrolysis cell important. Blast furnace and what are the things added, and we use each one for what important. Okay, this collected in the question uses of iron, kinds of iron. Okay, rusting, what does it mean by rusting, and the need what to occur here, how we can preventing rusting, what does it mean by galvanized iron, like this. Okay, the work in blast furnace summarized in this question 3. Okay, thank you, best wishes.